So today we're introducing the Functional Safety Series Back to Basics. I wanted to tell you a little bit about the concept behind it and the why, and then start the process rolling, show you exactly what we have been teaching and the start of it. So this year we created a new series of webinars and articles and blogs called Back to Basics. And in the Back to Basics series, we're going to discuss everything from functional safety, like the general terms, descriptions, all the way through topics of more advanced subjects like component analysis. Before I started working here at Exida in functional safety, I was a mechanical engineer, but I never worked in functional safety before. I was in design and manufacturing of different products, and we never needed functional safety. Needless to say, when I began working here, I had never heard of common standards like IEC 61508 or IEC 61511. Those sounded more like telephone numbers than standards to me. And I had no clue what this SIL thing was. When I took on this new functional safety role, I remember trying to, learn as much as I could and take it all in. And in doing so, trying to keep track of all of the new terms, definitions. There are so many three-letter acronyms to keep track of. At times it felt overwhelming. Now, go ahead and fast forward 6 years. I've been here now, and I know all the standards. I can tell you all the standards numbers back and forth, read them all, and I can also now not only tell you what SIL stands for, but all of the fun ways you can use it. So why am I telling you all this? Well, I started helping Exida Academy and I became an instructor. And when I did so, I started teaching the FSE 100 class. And that is the week-long class on functional safety. And it has a lot of information in it. And I quickly found that many people were in the same boat as I was when I first started here. And this was regardless of their years of experience. They maybe had never been introduced to functional safety before, or they didn't know the basics and were never taught the basics. I know when I was first learning the subject, I was almost timid. I did not necessarily want to admit I didn't know something, or I didn't want to ask too many questions and fear that maybe I should have already known this. And maybe a couple of you listening might be in the same boat, or you realize that maybe you have been in the same position. I found that more that I taught, the more I found that more people were in that same spot as I was. And this isn't just with functional safety, but when you're starting anything new, you trying to get all of that knowledge can be daunting. And this is why I wanted to create a space that can be that kind of go-to knowledge for any functional safety basics. And as I said before, we're going to start very general in terms of what functional safety is, the standards, and then expand into more specific topics, both OEM and end user specific. When we introduce topics, I'm going to try and have terms, definitions, examples, pictures, as many items as possible so that it can be explained in a way that anyone can possibly understand. So today we're going to start at the very beginning, and we're starting with those very basic blocks. What is functional safety? What are the functional safety standards and what do they say? And then we're going to get into a couple of those three-letter acronyms that get thrown around a lot. SIL, SIF, and SIS. And then also, what is a safety function? So we will go ahead and get started into this webinar and take a look what all of that means. I kind of already told you about myself. I work here at Exida for over 6 years now, and I work with both Exida Academy and training, and also in Exida helping my customers get through the IEC 61508 certification process. A little bit about Exida. If you're unfamiliar with us, we're involved in functional safety from the complete supply chain over multiple different industry sectors. So whether you're making the products that need to be certified that go into safety systems, or if you're the end user using them, or anyone in between, we have people and consulting and tools and training and procedures and templates and anything that can really help make your job smoother and easier. And we have this in functional safety, alarm management, and cybersecurity. I like to say no matter where you are or your products are coming from or where they're going to, we have somebody close by that can help with each way of functional safety. And this map isn't even up to date. We've opened more branches this year that haven't been updated on this map yet, and I should probably do that, sorry. But we have experts close by in functional safety, alarm management, and cybersecurity. And then lastly about Exida, I like to make sure that everybody's aware of this slide because I feel this is very important. When we research, when we're working on any of our research projects, when we are analyzing it, how we are doing our procedures, everything we work on and look at is an open book. We feel that if the research we're doing is making the world a safer place, we want to get that information out there. So we have books, we have these webinars, blogs, articles, we go to conferences, we give speeches. We're trying to get that information out there as much as possible. So if you ever do have any questions, these books, these references are great places to look for. But let's get back to why we're really here and the beginning, or those first building blocks of functional safety and what it is, what are the standards, and a couple three-letter acronyms that get thrown around the most. Let's go ahead and get started. If you have any questions throughout the webinar, please feel free to type them in the questions panel. I'm not the best at stopping and looking to see if there are any questions throughout the webinar, but I will make sure to pause and take some time afterwards to answer any questions if you have them. So the first concept, or the first term that comes around in functional safety, well, it's functional safety. What exactly is functional safety? What do we mean by that term? Well, functional safety means the automatic safety function will perform the intended function correctly, or the system will fail in a safe manner. So, to improve plant process safety, functional safety systems enable some sort of orderly shutdown of process units when an abnormal or some kind of weird or hazardous situation occurs. If that situation is beyond the capabilities of your regular control system, or beyond the capabilities of your operator to be able to correct the problem, those safety systems come into play to try and prevent a major catastrophe from happening. Functional safety enables that freedom from too much or excessive or that unacceptable risk. And it's achieved through following something called the safety life cycle. And we will look later in this webinar what the standards say about that safety life cycle. In general, functional safety, it has been adopted from two main industry standards, IEC 61508 and IEC 61511. And we're going to see what those are next. So what are functional safety standards? There are many different standards out there in functional safety. The overall, or the main standard, is IEC 61511. It is sometimes referred to as the umbrella standard because it kind of covers all of the other standards that fall beneath it. It's targeted towards OEMs or manufacturers. However, underneath it falls more specific standards for each industry. So if you are in automotive or nuclear or machinery or process industry, under this IEC 61511 or 508 standards fall those more specific standards. And we're going to talk about the two primary standards that come up in functional safety and in the process industry, which is IEC 61508 and IEC 61511. And we're first going to look at IEC 61508. The newest version has been released in 2010, and it is in terms or in the eyes of manufacturers. So it is going to be talking about how to build a device and make sure the device is going to work correctly. It's going to apply to any automatic protection system, and it helps shield against both random hardware failures and systematic design failures. Some of the great things about IEC 61508 is the way it was written. It can be applied to both project and product level work. So that could be the same device that's sitting on the off-the-shelf use in many different applications, or it can be applied to making a specific product for a specific customer. It's also a performance-based standard instead of a prescriptive-based standard. The great thing about it being performance-based is it gives you end goals which you want to achieve, but it lets each company individually decide how they're going to achieve those. If you had a prescriptive standard, like a lot of the standards are, it gives you the steps and the directions. Step 1, 2, 3, 4, in that order you must do. However, IEC 61508 gives you your performance goals or those end targets to shoot for, and you yourself can decide how exactly to implement them. IEC 61508 came about by people from different working groups and national standard bodies from all around the world came together because they wanted one area for functional safety because it was scattered throughout many different standards before. And they wanted to bring it together under one document, one big standard, and they made IEC 61508. From that standard, it then branched out into more specific those industrial standards that we talked about, like the automotive or nuclear or machinery, or the process industry like IEC 61511. As I said earlier, it was originally made in 1998 and 2000, but the latest edition has been updated in the 2010 version of the standard. And the standard talks and is targeted to suppliers or those people making devices. And it's mainly used by safety equipment suppliers to show that their devices, that their equipment is suitable for use in safety systems. It contains requirements for those suppliers or those manufacturers of process controls and instrumentation for component, element, and subsystems. And because of those requirements in the standard, a lot of end users usually seek suppliers that have products that are certified and proved that they meet all of these requirements by a third party. In most situations, the standard is typically cited as best engineering practice or common engineering practices, and it is often required by end user customers as part of contractors for manufacturers. They want to make sure the devices they're going to buy meet the requirements in the standards. A couple fun facts of IEC 61508. As I said before, it was that first standard of functional safety. It's the standard which all of the other functional safety standards got developed. And it's nicknamed that umbrella standard because it covers everything else. If any of the standards don't cover a situation or an example, they always refer back to IEC 61508. Anyone making safety-related systems should be following the standard. It's broken apart into 4 kind of requirement sections and 3 guideline parts in the back. It defines the concept of what SIL is and shows you exactly how a device can meet that SIL, and it defines what a safety life cycle is and even gives an example of a safety life cycle to follow. There are certifications to show that you meet the requirements of the standard, and the certification portion is optional. However, meeting the requirements in the standards or in IEC 61508 is not. And that certification is what is usually valued or expected by those end users. IEC 61508 started back in the day as a non-governmental, just an industrial standard, and it's growing and growing in both its use and its enforcement. Currently, its level of use and application is so prevalent in the whole world that it can almost be hazardous for an organization to ignore the recommendations and requirements of the standards. As all or most societies are becoming more risk averse, especially if you're living in the United States or the land of litigation, having compliance with IEC 61508 is becoming all but mandatory in parts of the industrialized worlds. In some countries, the standard has been accepted by law of governments and its use by force of law. However, in most situations, the standard is cited as best engineering practice or common engineering practices. As I said before, it's often required by end users as part of contracts. And if an accident or when an accident does happen, the standard can be cited in civil cases as that common or best engineering practice. It could be a trial where the engineers get asked, well, everybody knows about this standard, and most of the world is accepted in doing this. Why were you not? And at that point, you would have to defend why you did not use common or best engineering practices. Even though it wasn't required by law, I still wouldn't want to find myself in that situation. In IEC 61508, it talks about using, and it recommends using the use of a functional safety life cycle. It talks about any safety life cycle can be used, but it does give you an example of a life cycle that can be divided into 3 main portions. You have your analysis, your design and implementation, and your operation and maintenance phase. And each step of this life cycle has inputs, outputs, and you go back if you have any modifications or issues. On the other hand, we have the other standard, IEC 61511. So as IEC 61508 talked to those manufacturers, IEC 61511 is in terms of end users. So it's going to tell you how to take those safe devices and how to use them properly. It is a technical standard that sets out practices in the engineering of the systems that ensures that the safety of the industrial process through the use of specific instrumentation. It has all the requirements for the users of that process control and the instrumentation or those elements listed just as IEC 61508 had it listed for the manufacturers. The main objective of IEC 61511 is to use safety instrumented systems to reduce risk to some tolerable level by following a safety life cycle and maintaining the associated documentation. Just like IEC 61508, the standard focuses on a life cycle that processes and tries to manage risk. IEC 61511 was originally published in 2003, but its latest edition and rev was published in 2016. A couple fun facts about IEC 61511. Just like IEC 61508, it applies to any automatic protection system. It falls under that IEC 61508 umbrella. So if you ever find a requirement that isn't listed in IEC 61511, it says, please go back to IEC 61508 to see what it says about it. It is broken up into three main parts. One of that rules and regulations and two of the guideline parts. Just like IEC 61508, it gives a definition of the concept of what a SIL is and what safety systems are and what that safety life cycle is. However, this time, it's how those end users can use SIL and how they can figure out how much risk they need to remove from their plant. IEC 61511, just like 508, recommends the use of a functional safety life cycle, and any life cycle can be used, but the standard also gives you an example and lays out a process which is pretty nice and easy to follow. Just like IEC 61508, it's broken up into three main sections: the analysis phase, the rationalization phase, and the operation phase. In the 2016 edition of the standard, it addresses cybersecurity in the life cycle, and it's just showing how more and more of a concern cybersecurity is being, and addresses that. The new standard addresses that. So now we know what functional safety is. Let's look at the term, what is a safety function? So I'm a very visual person, so I like lots of pictures. This is an example of your basic process control system and a safety function wrapped around it. So in that green area is your BPCS, or your basic process control system. And you can see in that peachy color wrapped around, you have your safety function or your safety system. So your safety function is going to be the action of a set of equipment to make sure that a particular hazard doesn't happen or it gets mitigated. It is the job of the safety instrumented function, and we'll learn about that later on in the webinar. So as you see here, you have a safety function. It has its own sensors, logic solvers, and final element that can control the process besides the normal operating process. So with a safety function, you're going to want to realize that there's a problem and act upon it. So what are some examples of safety functions that you could think about? Well, an example that most people pop in their mind right away if you're in the process industry is an emergency shutdown valve, or an ESD valve. What does that do? It definitely will shut down the process. So we're looking for the valve to shut down the process. Another example of a safety function is a sprinkler system. Upon of realizing there's a fire, the sprinkler system decides to act, puts on the sprinklers, and mitigates your issue, hopefully. Other examples of safety functions: high pressure in a vessel opens to vent a valve. Even your car, your brakes and your car brakes stop. If you have guards against sensing or speed sensing functions on motor controllers, if something goes out of control, if a coolant vent needs to open, or overflow sensing functions. One thing that we get asked often is, what about an alarm? Is an alarm an example of a safety function? So thinking about it, on detecting a fire, maybe an alarm triggers and it minimizes the damage and possible injury. So would that be a safety function? Well, no, not really. Yes, it's doing a great thing. However, it is not a full safety function, since it never achieves that safe state. It never tries to mitigate it. The hazard. So remember, for it to be a safety function, it needs to implement that automatic mitigation of a particular hazard. So that final action must be included. But if that alarm system was tied to your sprinkler system, now we have a safety function. The next section is SILs and SIFs and SIS oh my. So what do these all really mean? As I told you earlier, there are so many three-letter acronyms in functional safety. It's pretty much a joke around here. Three of the most common and heard of acronyms that in the basics of functional safety are SIL, SIF, and SIS. Where SIL is going to be your safety integrity level, your SIF is your safety instrumented function, and your SIS is your safety instrumented system. And we're going to take a look at what those three acronyms mean as well. So first, let's jump into SIL. That was one of the first terms I heard when working here. And if you're new to functional safety, maybe that's one of the first terms you hear as well. I know that there's some people that know nothing about functional safety, but they've heard, oh, I need a SIL too. So what does SIL actually mean? Well, SIL stands for Safety Integrity Level, and it is a quantitative target for measuring the level of performance needed for a safety function to achieve that, how much risk they needed to remove from that hazardous condition. Safety integrity levels are defined in both IEC 61508 and 61511 standards, but as you know now, they're in different verbiages and different tones, so they're going to define SIL slightly different. IEC 61508 talks more on how the devices are put together and achieve SIL, where IEC 61511 talks more on how the end users can use those numbers and estimate how much risk they need to remove. Defining a target SIL level for a process should be based on the assessment of the likelihood that the incident will occur and the consequence of that event happening. Oops. Your SIL level is going to be 1 through 4. There's 4 options there, where SIL 1 is the lowest and SIL 4 is the highest. SIL 1 doesn't have as many requirements to meet if you're going to have your device certified. And each sill you go up, there are more and more requirements. Just like each sill you go up in the end user is an order of magnitude difference. In IEC 61511, they actually only define SIL 1 through 3, as it's kind of a rule of thumb in the process industry that SIL 3 is really going to be the maximum. There's always exceptions to the rules, like in rail or nuclear, but this is one of those cases where IEC 61511 says if you need information for SIL 4, please refer back to IEC 61508. Both of the standards have these tables associated with the SIL, and they will let you know for each SIL what numbers you need to meet for probability of failure on demand, risk reduction, hardware fault tolerance, even architecture. So these SIL levels are key pieces of information for both end users and OEMs to communicate about. Overall picture, what is SIL? SIL is going to be a measurement on how well a safety function actually does its job. How much risk your safety function is going to take out of that system. So the next term is a SIF. What's a SIF now? Well, a SIF is a safety instrumented function, and this is a set of equipment intended to reduce the risk for a specific hazard of a safety loop. So its purpose is, first of all, to automatically take a process to the safe state if some condition is violated or if some hazard occurs or some weird condition is happening. First of all, either take it to a safe state, or it can permit the process to move forward in a safe manner with things called permissive functions. Or it needs to take action to mitigate the consequence of an industrial hazard. So your SIF is going to be a collection of instruments of sensors, logic solvers, final elements put together to prevent one bad thing from happening. It includes elements that detect that something needs to happen. It includes elements that decide that you need to take the action. And then it includes elements that actually carry out that action to bring it to the safe state. So it needs to have an ability to detect, to decide, and to act. If so, then it will have a designated safety integrity level for that function. So if it is able to decide, or to detect, to decide, and act, it protects against one hazardous condition, it can have an associated SIL with it. Each individual safety functions, or safety instrumented functions, or SIFs, they're going to realize that, it first needs to identify the need to act and bring the system to a safe state for each hazardous scenario. But remember, it's for one set of actions against one hazard. So what kind of examples are some things of SIFs that we can talk about? Once again, remember, we're looking at a single action to identify, make a decision, and act on a single hazard. So some examples could be on detecting a high temperature. You could prevent column rupture by shutting off steam flow to a reboiler, or on detecting high pressure. To prevent tank rupture, you might open up a valve to relieve a system. Or what about if you have a sensor that detects a high level? It could open up a drain to an excess, to make all of that excess liquid go to a sump pump. So maybe it doesn't overspill a container onto and have you deal with environmental damage. Or or you could have a motor, you could stop a motor by disconnecting the power or activating a brake when you notice that it's overspeeding. Just like before with the example of an alarm, that is not going to be a complete SIF. If you have on detecting a fire, an alarm goes off and alerts an operator. It doesn't take anything to that safe state. You don't have any final actions. If that was connected up to the sprinkler system, different. So overall, your SIF is going to be a collection of equipment that has a specific job or that safety function. And it's going to look for one hazard and act to make sure that hazard doesn't happen. Each SIF, if it's doing its job and removing risk, will have an associated SIL level with how much risk it is removing. So in that case, what is a SIS? Well, a SIS is similar to a SIF, which is super confusing. A SIF is a safety instrumented system, and it can be built in one or more than one safety instrumented functions. So if you look here in this example, and this is a lovely SIS, and as you can see, this example of this SIS is built with 3 different SIFs comprising the system. As you can see, your SIS can be composed of any combination of sensors, logic solvers, final elements. You can see they can even share components, and that's fine. Your system usually have a number of different SILs associated because each of your SIFs have a different SIL level with it. So you might have 3 different SIFs with 3 different SIL levels. So it's technically wrong to say you have a SIL for your entire system or your SIS. So those were some of the topics that have been covered already in some of the blogs and articles, and I wanted to get a webinar up to speed, but I wanted to give you a sneak peek on what are the articles and blogs to come as well. So now that we know what a SIF, SIS, and SIF are, and SIL is, now we want to know, well, what does that SIL mean? How does a product get a SIL level? How is that SIL level used by end users? And what is that certification to a SIL level? And with those, there's going to be upcoming webinars, blogs, articles, and LinkedIn posts as well. So once again, I wasn't the best. I didn't take time for questions throughout, but I will now. Let me get it on open. And if you have questions later on, please feel free to contact us. If you want more information, reach out. And if you really loved learning about functional safety and you need more in your life, we have more intensive trainings than these little 30, 40-minute webinars. We have day and even week trainings in multiple different subjects. If you can't make it to a live instructor, we even have some online self-paced training. If you want more information, always follow us. We always try and keep that up to date with the latest information, and check back in definitely for more the Back to Basics blogs and webinars. At this point, okay, there we go. I was going to say we didn't have any questions. One just came in. One of the questions was asking what are some of the other blogs that are coming. Will you be doing a session on the changes from the old version to the new version of IEC 61511? To be honest, Kirk, I don't have that one written yet, but that's a great idea. I love that idea. And I think that that will definitely be a topic upcoming. We have a lot more acronyms like safe failure fraction, as we have architecture coming up. We have end user and OEM terms and all about failure rates coming up as well. So stay tuned. If there aren't any other questions, thank you for joining us today, and hopefully we will see you back for more. Thank you.